Welcome to Modern Retrogramming with Plasma. In this video, we're going to explore LISP 1.5 with an interpreter written in Plasma called DRAWL. Yes, a slow version of Lisp in keeping with the speech theme. DRAWL is a REPL, read, evaluate, print loop, sandbox used for experimenting with S expressions, the heart of Lisp. LISP 1.5 traces its history to the early 60s, so it should be pretty doable even on an Apple II. One big issue, however, is the limited recursion available to the 6502 CPU and Plasma. Let's investigate how far we can go. The traditional function for a recursive example is factorial. Here we have a factorial lambda function, and showing the conditional clauses, these are actually able to be separated with a comma. LISP 1.5 treats commas just as spaces, helps just to syntactically separate the two. Let's see when we run the factorial function how far we can go until we find the limits of the system. As we start, we'll start with factorial of 1 and start increasing it. You'll notice that the numbers will start to exceed what a 16-bit number can express. DRAWL uses 32-bit numbers for the basic math operations. They're starting to get bigger and bigger. Here we've exceeded what a 16-bit number can do. But here comes the drum roll. Oh, I think we found the limits of our recursion. Well, let's do a quick reboot here. Another mathematical example that's included in the LISP 1.5 programming manual is greatest common denominator. This was based on an algorithm that was devised some time ago. Here we'll run the greatest common denominator function a few times in DRAWL. Again, all these examples that we're going to run came from the LISP 1.5 programmer's manual. I'll provide a link in the comments to the GitHub page that has more information about DRAWL and where you can get floppy disk images and the manual for LISP 1.5 itself. Well, these are just showing off some of the mathematical capabilities of DRAWL. No floating point, unfortunately, is included, but 32-bit integers are. Let's run some programs that operate on lists. Here is using a set. It will read in 3 functions that work as a member, union, and intersection of sets. We'll use setQ, which is from part of the LISP 1.5, to set variables that we can then use as parameters to our lambda expressions. We'll do the union of L1 and L2. And again, the intersection of L1 and L2. That's kind of case insensitive. Everything gets converted to uppercase and internally. I just used uppercase L1 and L2 just to differentiate them from ones. Map list is an interesting set of lambda functions. In fact, this is using an anonymous lambda function as a parameter to the map list function. You can see where we actually quote the list for the lambda inside of y dot, and that then is passed in as a function which is called inside of map list. So you can apply different functions to items in a list. In this case, it will dot each element in the list. It's not very exciting to watch, but it's kind of interesting when you look at the code, how it all operates. It's all done with recursion. None of it uses loops or go-tos or any such thing. It's all based on recursion, which is why it makes it very interesting to be doing this on an Apple II with a little 6502 and limited stack space. So yeah, so that went through and just added a .z to the main elements in the list. Included is the Plasma source code for DRAWL so that you can edit and compile right on your Apple II. You see you have two Plasma source files. The drawl.pla file is just the REPL part of the DRAWL package. It links to the S-expression module that does all the heavy lifting for the S-expression evaluator. Well, if you go to modify the DRAWL environment, you can go through drawl.pla and add new variables, native functions, whatever you'd like to improve the environment. You could even go so much as to add floating point numbers. All is possible with this environment. So thanks for coming along for this excursion into Lisp and Plasma. Thanks for watching.